Okay, this is the video tutorial for lesson 11.1, equations of circles, and we're going to find the centre and radius of a circle for an equation in any form. We're also going to switch between different forms and figure out different properties of circles. This used to be something that was covered in in Algebra 2, but it seems to have been removed in recent years, so some of this stuff might not have been seen since geometry, or possibly not at all. So this is the warm-up. If you want to pause the video and have a try at the question, you can certainly do so. So one of the key things for this is noticing which distances we actually know. So I've kind of created the shape here. If you can try and label as many sides as possible, then that should enable you to actually work out the distance BC. And the radii, the radius is 10 and 6, so this side's clearly 16. The height is 6 here, and the height is 10 here, because it says it's the radius of these circles. So what I did is I brought a perpendicular across here. So notice that's the same as BC though, and if this is 6 and this is 10, then that distance there must be 4. And then you can use Pythagoras on this right angle triangle to find that distance. This is actually only a GCSE question, so that's something you're supposed to be able to do before you actually get to AICE 1. So specifically for this unit, we're going to recognize the form of the equation of a circle and understand the nature of implicit equations and be able to differentiate them. I always start with the circle part. Really the title of this unit is implicit differentiation, but as it uses circles so much, I think it's important to make sure that we know how to do circles. And if I remember correctly, a question actually came up in chapter 10 as well about circles, so I said that we would revisit it at that point. So a couple of definitions to get started. Standard form of a circle, x minus a squared plus y minus b squared equals r squared. You certainly might have seen this one before. The American term is really center radius form. I can tell that from the spelling down here. The English spelling would be RE for center. General form, that's when everything equals 0. So basically it's all this multiplied out. You'd substitute in for r, and then you would multiply out to get there. And we're going to be able to go from here to here, and also from here to here. Sometimes it's useful in this form, and sometimes it's useful in this form. So if we're given a picture, we also need to be able to find out what the equation is. So the key things on here is I need to know what the center of the circle is, that's the h and the k, and I need to know what the radius of the circle is. Notice on the scale here, you can see each square is 2 units as well, so that's important. So that's clearly the center where I have the little arrow right now, so that would be at -5, -2. So when you substitute in there, the negative of -5 would turn out to be +5. I can probably go down a little bit lower. There we go. And the opposite of negative of -2 would give me +2. I would normally just go straight from here to here, but if you need to summarize first and then substitute in, you can certainly do that. So the radius is the distance from the middle to the center, so 2 squares, so 2, 4, as each square was worth 2, and then 4 squared equals 16. To check that you understand, you should pause the video and try and answer this question as well. So the center of the circle is clearly where the arrow is, which would be at the coordinate 1, 4. We also have a scale of 2 here again, so the radius this time would be 2. And then once I've got that, I can do the opposite. So instead of 1, -1. Instead of 4, -4. Radius was 2, so 2 squared is 4, and we would be finished. When we're going from the general form to standard form, so in other words, the reason we like this form so much is you can easily pick out what the center and radius is. So when it's written like this, it's not so easy to do. So what we're going to do for this question is we're actually going to complete the square twice. We had those squareds there before in parentheses, so that's what we're going to try and recreate. So I'm bringing my x terms together, and I'm bringing my y terms together, and I'm going to move all the numbers to the opposite side, because eventually this will equal r squared. Now, when you complete the square, you do half the coefficient of this number here, which is -4, and then square it. Now, if you do FOIL on this, if you remember from AICE 1, you would get x squared minus 8x, but you would also get -4 squared, which is 16. Now, I don't want 16. In fact, I don't want anything here. So if I subtract 16, that would actually give me the same as this expression here. Do the same for this one. Half the coefficient of 4 is 2. 2 squared is 4. I don't want 4, though. I don't want anything. I want 0. So I'm going to subtract 4. And then from here, I can start moving terms to the other side of the equation. So that should give me 36. And then from there, this is r squared, remember. So that means that the radius would be 6. And I can pick out the center by just doing the opposites of those two terms there. and I went to the English spelling of centre there, of course, with this being an AICE class. If you want to practice that skill, there is a couple of questions you can try. The answers are at the bottom, so it's kind of like a show that question. But just make sure that you can switch from this form to this form, mainly in case what they ask you is what is the centre or what is the radius. And sometimes that's going to be a useful application. From here, there's some worksheets to try. Go find those and start working through those. Some questions not quite covered in here, some require a few algebra skills. But of course, that always happens on ACE anyway. You might get something that you're not quite used to, and you've got to try and figure it out a little bit.